Hi, I'm Cheryl Leach. In this exercise, we're asked to evaluate a definite integral. We're going to be looking at the integral from pi over 2 to 2 pi over 3 of secant squared of x divided by 2 dx. Now, I notice that this integral is too complicated to just use my basic integration techniques. So I have to look at what other techniques I can use. Well, when I look at this, I notice that I have a composite function. I'm composing x divided by 2 and the secant squared function. So I'm going to use the substitution technique. So let's do a little side work so that I can get the constants right, because I notice that if u is x divided by 2, I don't quite have the right combination in my integrand. So let's take a look at the integral of secant squared x divided by 2 dx. U is going to be x divided by 2, which means that du is going to be 1/2 dx. Now I mentioned that the constants didn't fit exactly right. Well, this is what I mean. I need a 1/2 x in my integrand, and I don't have it. So I'm going to put 1/2 x in. Excuse me, just 1/2. In order to do that, though, I also have to multiply by 2 so that I don't change the problem. So I'm going to have 2 secant squared of x divided by 2 times 1/2 dx. Now I notice that my du is exactly where I want it, and I can take secant squared of u times du. So what do I have? The integral of 2 secant squared u du. Now I have a basic rule for this. First of all, the 2 is a constant multiple that we'll pull out, and the integral of secant squared is tangent. So I have the tangent of u plus my constant. Integration's over, so I can go ahead and get the x's back. So I have 2 tangent of x divided by 2 plus my constant. All right, so that's the indefinite integral, but I want this to be a definite integral. So what I notice is I'm going to be integrating secant squared of x divided by 2 dx. I know that's going to be 2 tangent of x divided by 2. And instead of the constant of integration, I'm going to be evaluating this thing from pi over 2 to 2 pi over 3. So by the fundamental theorem, I need to plug in the upper limit and then subtract what happens when I plug in the lower limit. So I'm going to have 2 times the tangent of 2 pi all over 3 divided by 2 minus 2 times the tangent of pi over 2 all divided by 2. Okay. When I reduce those fractions, I'll have 2 times the tangent of pi over 3 minus 2 times the tangent of pi over 4. Now, pi over 3 and pi over 4 are both special angles, so you should know how to evaluate the tangent of those angles. So the tangent of pi over 3 is the square root of 3. So I have 2 times the square root of 3. The tangent of pi over 4 is 1, so I'll have minus 2 times 1. So my result is 2 root 3 minus 2. Now, if you would like, you could also factor a 2 out of this and have this 2 times the quantity root 3 minus 1. Either of these answers are perfectly correct. I hope that was helpful. Thanks.